Hello, and thank you for your interest in our work on leveraging local neighborhood topology for large-scale person re-identification. Person re-identification is defined simply as the identification of previously seen individuals in one or more images captured from one or more cameras. It's an integral part of modern surveillance systems and remains a difficult problem due to many reasons. Re-identification problems are typically defined in terms of a gallery and a probe image set. And in the person re-identification literature, three standard scenarios are usually discussed. However, we feel that the most important distinction between re-identification scenarios is in terms of how much structure is or is not present in the gallery and probe image sets. On the left, for example, is illustrated an unstructured re-identification problem. In such scenarios, each probe image must be individually re-identified on its own. On the right, on the other hand, is illustrated a structured re-identification problem. In such problems, the unit of re-identification are groups of images known to correspond to the same person. Note that structured re-identification problems can be easier to solve. However, unstructured problems are much more realistic. Our goal in this work is to bring some of the advantages of structured re-identification to unstructured re-identification problems. We do this by building weak linear discriminants for each gallery individual, and then overlaying a conditional random field model on top of all available imagery. Inference in this conditional random field then leverages local structure and feature space in order to improve re-identification accuracy. Okay, let's jump right in. The first thing we do is fit linear SVMs to all gallery individuals in order to coarsely separate all images corresponding to each individual from images corresponding to other persons in the gallery. Note this is the only supervised portion of our technique. In order to map a re-identification problem onto a conditional random field, we first embed all gallery and probe images into a feature space. Then each observation is connected with its k-nearest neighbors. This k-nearest neighbor graph effectively approximates the local data manifold in feature space. Since our conditional random field contains nodes representing both gallery and probe images, a labeling in the CRF represents a solution to the re-identification problem. The energy function of a labeling is defined in terms of unary and smoothness potentials. The unary potential is defined using the outputs of the linear SVMs, and the smoothness potential is defined in terms of Euclidean distances between nearest neighbors. See section 3.4 for more details. We performed an extensive set of experiments in order to probe the effectiveness of our approach on structured and unstructured re-identification problems using a variety of standard publicly available data sets. Note that all parameters in our approach are directly estimated from the data as described in section 3.5 of the paper. In a first set of experiments, we demonstrated the effectiveness of our approach on structured re-identification problems. In such cases, instead of using nearest neighbors, we use the given group structure of gallery and probe image sets to define the topology of the CRF. In this table, our results are given in the last two rows, and we see that we significantly outperform the state-of-the-art in all configurations on all considered datasets. In a next set of experiments, we demonstrated how our approach performs on unstructured re-identification scenarios. In this table, our results are again given in the last two rows. We see from this table that our approach significantly outperforms the state-of-the-art, including other semi-supervised approaches like identity inference and manifold ranking. In a final set of experiments, we demonstrated how our approach scales to very large re-identification problems involving up to 30,000 gallery and probe images. Interestingly, the performance of our approach improves when more images are available. The results of these experiments demonstrate that the conditional random field is effective at leveraging all available imagery in order to better uncover local structure and feature space and improve re-identification. In this work, we described a semi-supervised approach to person re-identification that brings some of the advantages of structured re-identification scenarios to unstructured ones. Our approach performs very well even in cases of re-identification of very many probe images on the basis of very few gallery images. In fact, unlike purely discriminative techniques like SVMs, our performance actually increases with the addition of more and more test data. Thanks again for your interest in our work, and please feel free to contact us if you have any questions.